Hi. So this has been a great year for me. Dub was huge. A lot of things got sort of released and dumped on us, and I learned so much. So that's exactly the point. There's a ton that I don't understand yet. There's a ton of things that I'm still learning. It's just sort of the magic of what we do. We get to learn new things, and sometimes it's stuff that Apple gives us, sometimes it's third-party tools, sometimes it's something that a colleague says. And so a lot of what I try to do is not just give you code to take away, but it's this intuition. As we sit down with something, what are the big ideas? And so let's start with Swift UI. And here's an app I want to show you. I designed it myself. Thank you. Now, it didn't start as Swift UI. It started with a view controller. And so here's a view controller. And I needed to connect to my label. And so there's my IB outlet. And I needed a model. So there's my model. And I need to connect to the button. And so when I press the button, something needs to happen. And in this case, I increased the value by 1. And now I need to see the results. And so my button action says to the label, hey, can you update your display on the screen? And for many years we wrote code like this and we weren't ashamed of it. And why should we be? It was just MVC. But the problem with MVC is, of course, anyone can do it. That doesn't keep our jobs. We have to complicate things. So let's take our view controller and let's split it into pieces. And so we have our view controller and we have our view model. And our view controller owns our view model. And we know better than this. We were taught that if we do this, then we've got this retain cycle and everybody owns each other. And so we created a delegate protocol. And we call this the view model delegate. And our view controller conforms to the view model delegate. And our view model speaks to the view model delegate. And now you notice, even in this diagram, the view model no longer knows about the view controller, but the view controller knows about the view model. And this is the delegate pattern that we used for many years. In this case, we have our view controller. And our view controller holds on to the view model. And in this case, instead of doing the increasing itself, the model will do the increasing. And so our view controller will have this increased value that just turns to the view model and says, you do it. You increase the value. And so the view controller is communicating with the view model. So what does our delegate protocol look like? It has to have some sort of a method in it. And our methods and our protocols are something did something, something should something, something will do something. And so in this case, I have my view model did update my integer to something. So when I increase, it says, hey, I increased it by this amount. Aren't you going to do something? And because my view controller conforms to the view model delegate, it needs to implement that method, and it needs to say, hey, you're my delegate, or me, I'm your delegate. It's the one that knows both sides of it. And so I'm going to conform to my view model delegate. And in my view model delegate, I say, hey, view model, I'm going to play the role of your delegate. The view controller is your delegate, and so the view model says, fine, then you need to implement this method. That's our contract. And so the view model did update into, that's where it says, okay, you give me an int, I know how to display it. And we did this for many years. We had this nice delegate pattern. And the missing piece is the view model. The view model is now holding on to the view model delegate. It's got its own model. And when it's told to increase the value, it does this beautiful delegate question mark, this optional chaining, and says, if my delegate exists, I'm going to send it this message to go ahead and update its interface. And this was the delegate pattern that, I don't know how long you've done iOS coding or Mac coding before that, but we've been doing this for more than 20 years on the Mac. And then about 7 years ago, Apple said, yeah, don't do this anymore. They did this session on modern Objective-C before Swift was released, and they said, we don't want you to do delegates anymore. We want you to do closures, except because we don't have closures, we want to call them blocks, and we want the syntax to be horrible because we hate you. Now, soon we would get Swift and the syntax would improve and you would see why we want closures because they're so easy to pass around in Swift. And so in the view controller, instead of doing a callback, instead of the view model calling back to its delegate and saying, hey, do this, the view controller says, here's some behavior, I'm going to pass it forward. And so in this very high-tech animation, the view controller doesn't get a callback. The view controller says, hey, here's what I want you to do. I know, hours of animation. And so this is how we work with closures. We have our view controller. Our view controller is still holding onto the view model. It still has this thing where it increases value by asking the view model to increase the value. The difference is we don't have the callback anymore. We aren't conforming to a delegate protocol. And so we have to have this closure that we're going to pass forward. And so here's this closure we're going to pass forward. We'll give it a name inside of the view model. The view model will have this property called updater that can hold a closure. And I got to tell you, that's kind of magical. In Swift, we can just pass functions around like this. So we're going to pass this forward. So here's our view model, and it says, okay, when it's time to increase the value, I still tell the model to increase the value. And here is where I store this function that you give me. It's just this property, but its type is a function from int to void. So, when do I fire that property? One of my favorite things in Swift is the did set. And it sits here and says, I'm not going to do anything until the model changes. When the model changes, I'll go ahead and do my did set, and I'll call the updater on the model value. And so if you take a look at this, this is kind of very cool flow, and you'll find that you've actually been doing Swift UI for years. The user taps the button. This fires the action in the view controller. This call increases the model's value because I called increase value in the view model. So the view model says to the model, hey, increase your value by 1. And this is this single direction flow of state. Everything is going in one direction. And so the model is increased by 1. And then the view model says, ooh, did set. I notice that the model has changed, so it's time for me to call the closure. And when I call the closure inside of it has a link back to the label, and it can update the display. So this single path. And we bring this with us to Swift UI. Ready for Swift UI? Oh, it's about time. We're 20 minutes into the doc. We're not. Okay. Swift UI, we don't have view controllers. Oops. Not only that, but do you see content view conforms to a protocol named view, and it's a struct. In Swift UI, our visual elements are structs. In UIKit, our visual elements have to be subclasses of UI view or UI view controller, so they must be classes. And so I have these structs. And if I have these structs, I don't know what's going to happen here. So I have some model here. My value is an int. And I've got my body, which is where I describe what things look like. And my body looks roughly like this. It's some vertical stack, and inside of the vertical stack is a text and some horizontal stack, and inside the horizontal stack are 2 buttons. If I get rid of the layout stuff, really all I have is a text and 2 buttons. So I have a text and an increase and a decrease button. I designed it myself. Now the text is where we're going to display the description of the value. So we're going to display this int as a string. So texts know how to display strings. And there's some magic coming. My 2 buttons, I have labels on them. One says decrease, one says increase. They're stuck in this horizontal stack, so we're going from left to right. I've got increase and decrease. What do? Here's how you describe what a button does in Swift UI. You tell it what its action is. And because it's in a closure, I don't say value plus equals and value minus equal. It's got to be self dot, because I've captured the self. And we're so proud of ourselves until we remember we're inside of a struct. You can't change a property inside of a struct. If you change a property that is a struct inside of a struct, you're changing the struct itself. And Swift tells you things like, self is immutable. What do you think you're doing? So Apple says, aha, we can cheat. And they invented @state. And @state is magical because it says, here's the struct for content view, and instead of storing value here, I'm going to store value over here. And so what I've got from here to here with the @state is a reference. I've turned a value type into a reference type. It's an int. But now I have a reference to this thing that sits outside, and so you can change this thing that sits outside because it's not changing the struct. And oh my gosh, if we did that in our code, we'd hear about it, but Apple did it, so it's cool. And so here's the second bit of magic from SwiftUI. SwiftUI says, my text is displaying the value. If the value changes, SwiftUI says, oh, I'm going to throw out that text and create a new text with the new value. You say, well, why don't you just change the value? Because it's a struct. You can't change the value of a struct. You throw it out and you create a new one. Why don't you invent a new @state thing? Oh, that would be ridiculous. So here's our basic everything in one. And this is what most of the code looked like at DubDub. But we want our views to be as dumb as possible. Now, this is still a counter. And we would never do this for an example that is this simple. This code is much too complicated for this example. But I just want to show it to you. I want you to take it home and play with it. And now I have my view and my model. And in between my view and my model, I'm going to put some sort of a connector. Don't want to get religious about it. Some of you will call this a view model. Some of you will call it a presenter. Some of you will call it the chocolate festival. Whatever you call it. So here's what my model looks like. My model is a struct. We love models that are structs. So how do you increase the value by 1? If you were raised properly, you create a function like this that doesn't raise the value by 1. It throws out your model and gives you a new model where the model has been increased by 1. This look familiar? And when you first saw this, you thought, how wasteful? But this is the way we code in Swift. I don't mean wastefully. I mean we code like this in Swift. We have value types, and so we return a new model when we increase. We return something that would probably be called increased and decreased, because we've increased it by 1, we've decreased it by 1. So there's our model. Our view consisted of a label and 2 buttons. So what does our label look like? Our label looks like this. Our label is just something that says, what do you want me to display? Give me the string you want me to display. And so here's what the body looks like that actually does the displaying. It's just a text that shows that. And this is something I've been playing with lately, and I think I like it, which is in SwiftUI, I've been separating the view part from the struct part. So the thing that tells me what property it contains, I've been putting in the main struct, and in an extension that conforms to view, I've been moving the body. And I think I like that a lot better. It separates what it is from what it looks like. So there's my simple label. And so in my content view, my text value description is going to turn into a simple label. And so it's going to use this simple label. What does a button look like? A button is also going to be as dumb as possible. And so a button consists of what it displays and what it does. So here's what a button consists of in SwiftUI. A button is just the text it displays and the action it performs. And so here's what it looks like on the screen. When it's time to display it, it's just a button that shows me some text and has some action. And now I've got my model and I've got my view components. Let's build our connector that's between them. There's a lot of empty space. I guess I'll be filling it with stuff. So my connector has a model in it. And when the model changes, instead of using didSet, because this is a class, my connector is holding onto the model. Every time the model increases or decreases, the connector is going to throw out the model and replace it with a new one that's bigger or smaller. And so this model is going to change. And the way we do this in Swift UI, which uses combine, is we say the connector is something that can be observed. It is an observable object. And the thing that triggers the, hey, I've changed, is this at published. So every time the model changes, the connector says, hey, something's changed, you need to refresh yourself. So I conformed a custom string convertible, so if you want to see what I am, and you ask me, can you display yourself? I just tell you, I look at the model's value and I print it out. So if I start at 0 and I increase by 1, and you ask me to describe the model is now 1. And then I increase it and the model's now 2. So this makes it easier for us to display things. The connector knows how to increase and decrease. The connector is our view model. And it just turns to the model and says, hey, model, increase yourself. Oops, now you're a new model, so I have to assign it back to model. So there's my connector. You happy? Yes. We should say more. Okay, here's my content view. My content view has to watch that connector. So it creates an instance of a connector. Remember, the connector was observable. So from our point of view of the person watching it, we say, I'm creating a connector and it is being observed. So I am observing it. And so the content view is watching the connector to say when things change. And it's going to use that with its simple label, its simple button, and its other simple button. The simple label is just going to have the connector's description. So every time the connector changes, connector's observable, it publishes every time model changes. It says, I've changed. I'm the content view. I am observing the connector. I get this message saying, it's changed, so I need to update the label. I throw out the label. I create a new one with the changed value. What about these buttons? The buttons need an action. And the actions are connector increase and connector decrease. And so now I have my decrease button and my increase button, and everything is working through this connector. So way more code than before, but sort of conceptually easier. So we've been looking a little bit at combine. Let's look at combine, understanding that we could look at combine without looking at Swift UI. Combine does not require that you know Swift UI. Okay? So let's look at the target action pattern. And I want to share with you another app that I've written just for you. Now, you'll notice it's not just counting up, it's picking a random number between 0 and 2. This is very important. I'll accept that there wasn't thunderous applause that time, but you're on the hook for next time. So here I am in UIKit. I have my view controller. Seeing view controllers after you played with Swift UI is like seeing semicolons in Swift after you've been away for a while. So I have my IB outlet to connect to my label, and I have my IB action connected to the button. And what the button does is it says, look, when you press the button, I'm going to pick a random number between 0 and 2. Don't you love how easy it is to write random numbers now? Do you miss arc for random? Mod 7? No, you don't. Okay, so that's random numbers. And so there's my random number between 0 and 2, and I display it in text. And so I'm pretty happy with it. But this code is too simple. Let me bring combine into it. And the thing I get out of combine is I can get this single direction of flow. And so I still have my label and I still have my random. But this time, when I have my value, which is this int, the only thing I'm going to do here is pick a new value. You know when you have code that you hate and you get rid of it and you just feel so much better? That's where I am at this moment. Because I've gotten rid of the code where the button tells the label what to display. All the button is saying is, I just want you to pick a new random number. What you do with it is your business. I just want the model to pick a new random number. And so the model says, okay, I will, and I'll mark it as published so that when I I pick a new random number. If someone's interested in knowing it happened, I'll tell them. Who might be interested? A subscriber. How do we set up the subscriber? Well, we'll do that inside of ViewDidLoad, and inside of ViewDidLoad, we'll check our subscriber, and our subscriber will start with the value, dollar value. Well, remember that at state and at stuff, the property wrappers? That's what the dollar is. It's not exactly the int, it is bound to the int, so it's going to get the changes. You'll get used to it. You might not come to love it, but you'll get used to it. And so what this says is, I've got something that is tied to new values, that is emitting new values, and it's emitting ints. And what assign is saying is, at the end, I want to assign something to display labels text field. But display labels text field is expecting a string. We get a string to display, and you're giving me an int. How do I convert an int to a string? You say, well, if this was an array of ints to an array of strings, what would you use? Map. Great. So it's the same thing we use here. Look what you know already. And I use $0 there just to call out that we're using dollar in two very different ways here, because Apple hates you. And there's this pipeline that says, whenever I feel like it, I'm emitting an int. You're converting that int using map to a string, and then you're placing that string in display labels text field. And that's the target action pattern done with combine. That's kind of cool. So here's how we did it with target action, where we actually display text, and so it was less code, but it was more intrusive. And using combine, our action was a lot simpler, and then we had this pipeline that says what happens. So I got another example of combine, and then we'll go back to SwiftUI, and that is I pick a number between 0 and 2, and we're going to play rock, paper, scissors. So rock, paper, scissors, rock for 0, paper for 1, scissors for 2, and we've got a role for you and a role for the computer, so we've got to assign those things somehow to strings, and the last thing we're going to do is we're going to figure out who wins. And we'll display color with that. So again, I just designed this by myself. And I thought I would go until I won. And I thought I'd win sooner than this. Okay. So we have to fill the two labels. I should probably open source it, shouldn't I? So here's how I connect to my two labels. Here are my two publishers. Here are my two subscribers. And here's what I do when the button is pressed. I just pick two random numbers. And so I don't need to think about two different labels and what I'm setting up here. I'm just picking two random numbers. And then I have this magical function that says, if you give me any int, I'll convert it into a string. And if it's 0, it'll be rock. And if it's 1, it'll be paper. And if it's 2, it'll be scissors. But, you know, we don't trust people. So if it's outside, we'll turn it into Spock. And then if it's inside our range, we'll do the right thing. And so now you know how to change labels. Here's where we set our labels. We're just going to use this rock, paper, scissors to convert your value into a rock, paper, scissors and the computer's value into a rock, paper, scissors. And now the second part is how do we color the screen to figure out who won? So I need a function that figures out who won. And this function takes two ints in and returns a UI color. So if the first is the same as the second, I return the light gray that you saw. Now there are two ways for me to win. The two ways for me to win is I could be one more than the other person, and so rock, paper, scissors, paper beats rock, scissors beats paper, but then you have to wrap around, and that's the second one that says rock beats scissors. And then finally, if you didn't tie and you didn't win, then you lost and you return red. So I have a winner subscriber. And now I got to pull in two things. I got to pull in both publishers. And so I'm going to pull in two publishers, and I'm going to zip them together. And zip works the same way it does for arrays, where I take the first from each and I put them together, and the second from each and I put them together. And so I take these two and I zip the U value and the computer value, and now I've got a tuple. I can pass that tuple into the winner function because it's expecting 2 ints. It returns a color. I take that color and I assign it to the background color. Isn't that the coolest? Yeah. Okay. But even the validation I'm going to show you is kind of stupid. You're valid if you're an even number, and you're not valid if you're an odd number. And so when I have an even number, I'm green, and an odd number, I'm red. Hold the applause this time. And so in this case, I'm going to display something in the label just as we did before, and I'm going to set the color. And so you notice I set the color to red, and then I pick a random number. And so that's where I display the text. How do I display the color? So I'm going to have success subscriber, and on view_did_load, I'm going to connect them to each other, and I'm going to take my value, which is an int, and I'm going to decide if the int, so the background color is red, if the int is even, I'm going to turn it to green. So I just want the even numbers. If you had an array, how would you pull out just the even numbers? Filter. Look at what you know. So that's what we do here. We just filter, and we pull out just the even numbers. If it's even, then we go ahead and turn the color to green. Now, I don't know about setting it to red each time, so what I might do instead of this, and then assigning that to the background color, instead of doing the filter followed by the map, I might do a more complicated map so that this was my action. So my action only knew about the value. That makes me feel better. And I take my value, and I use a more complicated map that says, look, if you're a multiple of 2, return green, otherwise return red. Now, this is a better approach, but I wanted to show you filter, and now you've seen filter too. All right. So I have this methodology called hate-driven development, and it's based on looking at code that I hate and getting rid of it, and I hate this. I hate that I have all these subscribers and then I set them. I don't want those variables. I don't want to hang on to them. I just want to, in my view_did_load, maybe do this. In my view_did_load, I just want to hook my publishers to my subscribers. But the problem is nothing holds on to them, and so nothing happens. So I guess I need to do something else. Well, you've heard people say we don't have a dispose bag in Combine. So let me give you one. I just have an array of these guys. And so what I'm going to do is, for each one of these, I'm just going to add that subscription into my dispose bag. And so I have a subscription for my rock, and I have a subscription for my computers, rock, paper, scissors, and then I have a subscription for my who won, and they're all sitting there, and so I could remove them, but that holds on to them without me having all those variables. Or if you prefer, I could do it as a dictionary so that we could have names for it, and so I have my key value pairs for you, for the computer, and for the winner. So as you've seen, a lot of our intuition came from arrays. If I had an array of ints and I had this little function here, what happens when I apply that function? Every odd number becomes red, every even number becomes green, and so I end up with this array. If instead I get the numbers one at a time, as I do in Combine, they just come at me, then this 1 becomes red, 7 becomes, look at you, and 8, I think we can stop there. And so what we did with arrays these things are indexed over space, and what we do with these things that we get over time are very similar, and a lot of our intuition, a lot of these things that we do to manipulate them and combine sort of come from that intuition. And so we have a publisher, and that's my value that is doing the publishing, and we have our subscriber, and if there is no subscriber, the publisher doesn't send out values. The publisher's a busy person. It's got things to do, and if no one's listening, it doesn't talk. It's not like you and your child, right, where you just say things and they don't care. And in between is something we call an operator, and you might think of it as an operator subscribes to the upstream and the operator publishes to the downstream. A sign, though, it's not exactly subscribing to map, it's subscribing through map. And so without that assign at the end, you don't get a subscription. So the assign says to map, I'm interested, and the map says, hey, value, there's someone interested in you. And so it's subscribing through map. And that's a quick look at combine. One more thing to show you with Swift UI. In UIKit, when you want to present a modal view or you want to navigate in, all this navigation is done with one view controller presenting another view controller. One view controller presents another view controller. See, but Daniel, didn't you say there's no view controllers in Swift UI? I did. So I guess we can't navigate in Swift UI. Yep, no. That'd be dramatic, wouldn't it? So, everything in Swift UI is done through state. You change state, and something reacts to state being changed. So when we increased a value, that changed the value, it changed state, and the label, the text that presented that value said, hey, something's changed, I got to refresh myself. The same thing here if I wanted to show a sheet. I want to show a sheet, so somewhere I have state, and my state is some Boolean that says, right now I am not showing my sheet. And we need something that can change that state. So I'm going to create a simple button, and that button's action just says, change the showing sheet Boolean from false to true. And now you need something that reacts to what the value is. And so that's this sheet is presented based on that bool. So is presented was initially based on showing sheet, which was initially false. So is presented is false. When I start out, I'm not showing the sheet. When you press the button, is presented is reading off of showing sheet, which is now true. It says, ooh, I've got to show the sheet. What's the sheet? The sheet is another view. It's another struct. I'm just going to display a string in that struct. And so here is my sheet that I'm presenting. So my presenting view will say, oh, I need to construct a new instance of sheet, so I have to tell it what it's displaying. Now you will find, if you implement this code, you press the button and you show the sheet. And you're initially so proud of yourself until you think, how do I dismiss the sheet? The only way to dismiss the sheet is to change this state back to false. I changed it to true and it showed the sheet, and now that sheet is the frontmost view. How do I change it back to false? So in the sheet, somehow it needs to be tied to that state. The way we tie to state somewhere else in Swift UI is using something called a binding. So the at state was to store state locally. At binding is to tie to state that is passed to you. And so this says when I change showing sheet, I'm changing the thing back in my presenting view. And so there's my binding to showing sheet. So my presenting view says, okay, I have to pass along that information. And now my constructor for sheet says, here's the text you're going to describe, and here's your link to the Boolean so you can change it. And the sheet says, thank you. I need to add a button. Here's my dismiss button, and I will change showing sheet, not my showing sheet, but the thing that I'm bound to back in the content view. I will change it back to false. And this is this new way of thinking you're going to have to get your head around in Swift UI, where we have no view controllers, where life is declarative, and you spend most of your time modifying state. So that's a quick look at Swift UI and Combine. I hope you had a good time. Thank you.